Hello students, here are your, let me turn this up, here are your translation power notes. So remember that you can pause, rewind, whatever at any moment. We're going to start with some vocabulary. That vocabulary is going to be in those boxes in the top half of your notes template. Let's talk about the reading frame. The reading frame is a series of non-overlapping nucleotides on the messenger RNA that are read in order. And the codons have to be in the correct reading frame for a protein to be made. So the reading frame will be like this. So there's your first reading frame, and then it shifts over one letter. And any of these won't necessarily do anything until you get to the start codon, which is the all-important AUG. AUG is the start codon, and it's going to start translation. It will always code for methionine, the amino acid, which is abbreviated by MET. The ribosome, this is old news. I'm just going to go quickly through this. The one thing I really do want you to focus on is the bonds that are formed between amino acids or peptide bonds. This goes all the way back to September when we were talking about biomolecules, and the bonds that are formed and peptide bonds link the amino acid chain primary structure. Codon is just the set of 3 nucleotides that code for an amino acid. They come in threes. AUG, the start codon, codes for methionine. The anticodon is the complementary base pairs on the bottom of the transfer RNA that match the messenger RNA. Let me go back one. So here's the codon. UAC will be the anticodon. It does not code for anything. It just allows these base pairs to hook up for a hot tick on the ribosome in order to make that amino acid chain. Common language, this is the genetic code wheel. It shows you what codons code for what amino acids. I'm going to give you a copy of this. It's super simple to read. So let's take the AUG. The first letter is the largest letter, A. The U, the second letter is the medium letter, and then we go to G, and look, there's methionine, and we can do that for all 20 of the amino acids. Stop codon is pretty simple. There's no amino acid that codes for that, so that's the signal for this process to stop. Transfer RNA, we know its job. One end is going to have the amino acid, and the other end, which every time I move this, brings up that bar, has the anticodon at the bottom of it. There it is. There's the anticodon. Okay, so the parts of translation, these are all they. Just pause it right here and jot these down. I don't want to take up a lot of time going over those. Sites on the ribosome. The ribosome has 3 sites for all the different transfer RNAs. You don't necessarily have to write these down. It's pretty simple. The P site holds the growing polypeptide chain. The active site is where new transfer RNAs carrying their amino acids enter, and the E site is the exit site for the transfer RNA that has already dropped off its amino acids. So process. Initiation. The small ribosomal subunit will bind to the messenger RNA and read the start codon. Here comes tRNA with its anticodon, bringing its amino acid, will bond, and then the large ribosomal subunit will attach. Elongation, so to build the amino acid chain, the codon, so the P site is filled with the MET transfer RNA, then it'll read the next codon, the corresponding amino acid for that codon will be brought by the transfer RNA on the P site. When those 2 sites are filled, the 2 amino acids will be bonded together, and then everything will translocate. You'll see here that here's the bond that's formed, then everything slides one spot over, and then boom, there goes the empty tRNA to go grab another amino acid, and now the A site is ready to be filled by the next tRNA in line with its corresponding amino acid. Termination is when the stop codon is read. Remember, there's no amino acid for that, so it stops. There's release factors that free the polypeptide chain. Remember, it's only building primary structure. It will then be processed and folded to make a fully functional protein, but that happens a little bit later down the line. I want to show you this animation just to kind of help. Come on, hurry. So just to kind of give you a visual, it's happening. There's the initiation. There's the start codon with methionine. Here's another amino acid. They bond together. Right there is the peptide bond. Translocation, this guy's going to get kicked out because he's already dropped off his amino acid. Here comes the next tRNA. Again, second peptide bond, translocation, there goes that guy, and this process continues until a stop codon is read. And so that would represent a stop codon. Here come the release factors. Well, I mean, after the fact, obviously that brought one. There's the release factors. Now the whole thing is stopped. This is a misnomer. It's not technically a protein yet. It is an amino acid chain. All right, hopefully you got everything from that. Pause, rewind, and I'll see you soon.